The Automated Podcast.
So hello and welcome to another episode of Automated. I'm Mark Verbenkov and this is the podcast exploring the impact of technology on jobs. So about 6 years ago, I ended up moving to Montreal, and I think on my second or even third day, a friend of mine introduced me to a PhD student that had a small 3D printer set up in his place. So he actually explained how it worked and even guided me through the CAD program he used to design an object, and I was actually finally able to print a small square. But while the printer was rapidly moving back and forth, laying down strips of hot liquid plastic, we talked about the technology as well as its future improvements and the potential implications that it would have. So what really interested me in 3D printing were the possible impacts it would have on a number of different parts of the world, which I'll get into a little bit later in this episode. But what exactly is it, right? So rather than a subtractive process, 3D printing makes three-dimensional solid objects from a digital file. So an object is created by laying down successive layers of material, and each of these layers can be seen as kind of a thinly sliced horizontal cross-section of the eventual object. So 3D printing is really the opposite of subtractive manufacturing, which is cutting out or even hollowing out a piece of metal, plastic, wood, etc. So 3D printing enables you to produce really complex shapes using a lot less material than traditional manufacturing methods. One of the examples of one of these traditional methods is called injection molding. And this is where some liquidized material is forced into a mold. And I think one of the problems with this is that if any changes need to be made to the product or product line, new molds need to be made first. So 3D printing really offers more flexibility as there are no molds needed. You can just print directly. And the most common form of 3D printing is a technique that extrudes material from kind of a specialized head that then adds layer upon layer. So typically this is done with plastics, and it is the most common way that hobbyists use 3D printers. However, today's industrial-grade 3D printers offer much more refined and precise methods, which are also much more expensive, and are now typically referred to as additive manufacturing. However, both of these terms are used synonymously. So some of these more advanced and expensive processes even use laser melting to get really precise with the object that they're making. So naturally, with these new techniques, 3D printing has really evolved beyond just the basic plastic base materials that were used, and now you can also use glass, many other types of plastics, but even metals. But at its early start, 3D printing was used predominantly for something called rapid prototyping. So you can think about having a product idea, and instead of just having a paper or even digital image, you can print that product overnight, assess it the next day, and then make revisions and changes immediately. You can then repeat this cycle as many times as you need, and you can arrive at a final product much more rapidly than using traditional methods. However, as of 2019, the precision, repeatability, and the material range that I mentioned just before have really increased to the point that some 3D printing processes are even considered viable as fully industrial production technology. And this is where the term additive manufacturing has really been come to use synonymously with 3D printing. So some say that 3D printing has actually already reached critical mass within industry. And some estimates place that the entire 3D printing industry is expected to exceed $15 billion by 2020. So that's quite a reasonably sized market for one technology, but where exactly is this being applied to? So perhaps some more obvious applications that you may have come into contact with, even if you weren't even aware of them, are such things as dental products, eyeglasses, even lamps, furnitures, and even some shoes. So back in 2017, Adidas unveiled plans to have the midsole, which is a layer in the shoe that absorbs a lot of the shock, of their Futurecraft 4D shoe 3D printed. But these aren't really the applications that got me interested in my conversation with my friend about 3D printing. So what really interested me are some of the applications of 3D printing in places that might not seem so evident right away. So one of these first applications actually falls in the realm of healthcare. So back in 2011, I watched a presentation where Dr. Anthony Atala explained the research of regenerative medicine that he was working on. So in the talk, there was a 3D printer in the background putting down layers of material onto a weird looking ball that looked as if it had the consistency of some sort of jelly. So in his talk, he would go on to explain that the 3D printer was actually printing a kidney that could one day be implanted into somebody. So although this was just a demonstration and still has yet to be implemented yet, over the last 8 years, more simple organs, such as skin and even bladders, have been successfully implanted. And other parts, such as bone, cartilage, and muscle tissue, have actually been shown to be feasible already in lab conditions. In fact, during the presentation, a patient came on and explained the success of an implanted bladder that had already taken place 10 years earlier. So, though the more complex organs like kidneys, livers, and even hearts are still years away from being fully developed for printing and transplanting, of course, I was pretty shocked to be hearing this in the presentation. It also became immediately obvious to me that a massive impact with this would be on a very specific industry, if I can even call it that. So the illegal trading of human organs is actually estimated to generate about 1 to 2 billion US dollars per year, and it deals with roughly 10% of all transplanted organs. This is, of course, just an estimation, as it's really hard to get any solid figures on this. So kidneys are actually the most frequently sold organs and can go for as high a price as 200,000 US dollars per kidney. So if you're at all more interested in this, I'll have a link in the show notes that has a chart that shows the breakdown of the different organs as well as body parts that are sold on the black market. I know it's quite a dark thing to think about, but it is nevertheless a reality. And if the technology really does improve over the next coming decades, I think it's completely foreseeable that the black market organ trading job is something that we will only come across in our history books, at least hopefully. So still within the same domain, but on a much more positive note, 3D printed prosthetics have really become the go-to prosthetic of choice. So these 3D printed prosthetics are both much more affordable and can also be much more highly customized to each person's needs and wants. They are especially useful for kids, as resized models can be printed as the child grows and thus outgrows his or her prosthetic. But due to the customizable nature of 3D printing, there is even the possibility of making the prosthetic highly customized and even artistic for each individual. So some examples are of having a red Iron Man looking hand for kids, or even a chrome colored leg for those who like to ride motorbikes. I even once saw an example of a 3D printed foot for a duck, and I actually checked, and Buttercup the duck was actually born with a backwards foot, making it impossible to walk around. But this was actually solved by having a customized 3D printed foot for the duck. So we can move on to the third application here. You might have also been hearing about the use of 3D printing within food. So there is, of course, an entire movement for specialty chocolates and cakes and desserts using 3D printing. But there was a recent story of astronauts printing a steak in space. So just last month on the International Space Station, meat cells were actually fed into a special 3D printer that then printed a steak. So though the finished product apparently had much to be desired, as explained by the astronauts, it nevertheless worked. So normally, just a 1 kilogram slab of beef takes around 20,000 liters of water to produce, but growing and printing the cultured meat takes up to 10 times less water as well as land and is much quicker to produce. And of course, doesn't require an animal to be killed, though it still requires a biopsy to get the initial cells. So the last application of 3D printing that really excited me about this technology when I first heard about it is related to much larger scale products. So contour crafting, though not exactly 3D printing, uses the same principles, but at the size of buildings. So instead of using the small specialized heads with materials like plastics and metals, contour crafting uses large concrete nozzles to add layers of a house or a building. So in much the same way that a plastic Eiffel Tower model is printed by a 3D printer that can then fit on your desk, contour crafting builds the shell of a building in an automated process. So actually back in 2014, a Chinese company was able to print 10 small one-story houses in 24 hours, but they were using 4 contour crafting 3D printers. But due to the lack of manual labor and cheap materials, each only cost about $5,000 to make. So the hope of the company is that the technology of contour crafting can advance to such an extent that in the future it will even be possible to 3D print or contour craft skyscrapers. So I think that contour crafting, out of the 4 applications that I've discussed briefly with you, is really the one that has potentially the largest impact on jobs. So even though recent construction worker statistics were really hard to come by, it's estimated that there's well over 100 million construction workers across the entire world. To give a bit of perspective, there's 10 million within the US alone. So as the work is incredibly varied, many have speculated that it's actually incredibly challenging to have robots replace humans in this work specifically. Also, there's an estimated 30% of all building materials that are actually wasted on typical construction sites. And just in the US, there are some 150,000 injuries on the job every year, with an average of 1,000 deaths, making it really one of the most dangerous jobs to be had. So I think that for these reasons, many claim that contour crafting is really a perfect situation to disrupt the modern construction industry by both drastically reducing the material waste as well as employee injuries. But I think that this is really going to come at the expense of potentially millions of jobs scattered across the entire world. So as I mentioned before, these were some of the first applications that got me really interested into 3D printing much earlier on. However, many 3D printing advocates have a much more ambitious vision, namely the ability of manufacturing most complex household objects from the immediate comfort of your own homes. So most cities across the world today have something called a Fab Lab. It's a small-scale workshop that offers people an opportunity to create objects and devices for themselves. But as we are seeing the trend towards personalized products continue to increase, having your own personal 3D printer would really enable the production of many everyday products we use to move into individual homes. So through this, we could see a massive reduction of goods transportation as well as overseas manufacturing demand. So rather than going to a store and buying a new cell phone protector or kitchenware or even many Christmas presents, you could just print them from your own home after downloading an image that you like or even designing one that you like yourself. So I think that here the impact on jobs could be very dramatic. So you can think about all the Amazon products that just could be printed instead of sorted, collected, and delivered by humans. However, even though 3D printers are dropping in price, some even go for as low as 100 euros, the trend seems to be that organizations are now offering their customers more customized options as 3D printers become faster, more efficient, and a feasible solution to traditional large batch size manufacturing methods. But what do you think? Would you prefer to have the convenience of a printer in your own house that you can then print a number of your products, or just to continue buying things as you are now? So there are, of course, a few problems with this vision. One being that the user friendliness isn't quite there yet for the general public, and some sort of digital design skills or CAD knowledge is still required to properly use most 3D printers today. However, the second, and I would say much more challenging issue, is that of something called the Liberator. So in the US in 2013, somebody by the name of Cody Wilson successfully test fired a handgun made almost exclusively from a 3D printer. Now, the design of the weapon was actually immediately released online for others to see and use. So since then, dozens of designs for guns, parts, and even ammunition have been made available, really making the legal and regulatory framework for home 3D printers quite a bit more complicated. But either way, whether 3D printers become a staple of every household, or whether corporations and hospitals and construction companies use 3D printers more, I think it will be a technology that will have a large impact on individuals, society, as well as the tasks and jobs many people are in right now. So thanks for listening to the podcast as always. Please leave a review, and if you have any questions or comments, please reach out via the website, automatedpodcast.org, or social media such as Twitter and LinkedIn. It's easy to find if you just type in Automated Podcast. Thanks again.
The Automated Podcast.